This very rare cartridge has been lost and forgotten about. There's no information about it out there, so our goal today is to restore it and preserve it because
it belongs in a museum!
Hello and welcome back to Noel's Retro Lab. A few months ago, my friend FX came over and lent me this odd-looking device along with some documents, and he told me I might be interested in it because it was extremely rare. I know it looks like some kind of weird CPU with two massive heat sinks on the sides, but it's actually nothing of the kind. FX is very involved in the MSX scene, and he has done some amazing MSX projects, including a port of Head Over Heels to MSX2, so you should definitely check them out, they're pretty amazing. So coming from him, it's no surprise that this was MSX related. It turns out that these metal pieces aren't heat sinks at all, but a very, very low-tech shell for a cartridge. Specifically, this is a cartridge for the SVI 328 that claims to convert it into an MSX-compatible device. The reason this is pretty rare is because it was created by a very small Spanish company called CCG. I was only able to find one article about it in a Spanish MSX magazine from 1987, covering it in detail, and afterwards, just a couple mentions, mostly in response to people writing in to ask about SVI compatibility. I wasn't able to find any advertisements in those magazines or any further articles, so I suspect it didn't last for very long and not many units were created. From the way it's constructed, I think it was made and assembled by hand, so I wouldn't be surprised if the total number of manufactured units was just in the hundreds. Looking around the internet, I see a couple of mentions, but no diagrams, no documentation, and no ROM dumps. So yeah, it's definitely pretty rare. I talked about the Spectra Video 328 in the past and where it fits in the MSX standard. As a quick review, it set the foundation for what it would become the MSX standard, but ended up being slightly incompatible. Mostly in the way memory blocks were paged, on the tables in the ROM for the different I/O ports, and the exact version of BASIC. In fact, the SVI 328 and MSX are so close that a lot of people have backported games from the MSX to the Spectra Video, and I suspect it's pretty automated once you know what to look for. It's a bit like the situation between the Dragon 32 and the Tandy Coco 2. And that's where this cartridge comes in. It claims to do that conversion on the fly and let you play MSX games on the SVI 328. I'm sure it has all sorts of asterisks and incompatible games, but it's a pretty cool idea anyway, and if it works with some of the more straightforward games, that would be great. In a future episode, we'll try that out and see what exactly it can do. So this is really neat, but there is one big problem. The cartridge doesn't actually work. When you plug it in, you just get a blank screen. Bummer. So let's open it up and see what we can do about it. We see that it has just one big screw holding everything together, and yeah, it all feels very much handmade, which is very charming and unique. And as I suspected, the whole device is just a ROM replacement. There's nothing else to it actually, just two EPROMs. They look to be 27C128, so that's 8 kilobytes each for a total of 16 kilobytes. That's actually great news. It means that one of these EPROMs has likely failed, and all we need to do is burn another one and replace it. Except that this is so rare, the ROM dump isn't available anywhere on the internet. So we have this almost historical device and all the data seems to be lost forever. Here's when I wish I could tell you that I recovered the data from the EPROM itself by analyzing the chip and doing some weird recovery, but it's nothing like that. It turns out my friend was in touch with another MSX collector in Spain who also happened to have the same SVI to MSX device, and he agreed to lend it to us. That should make reading the two ROMs and fixing this one really easy. So let's make sure it actually works. We pop it in, and yeah, that looks about right. The startup message is different and it mentions the MSX-compatible mode and CCG, which is the name of the company, so it looks like it's completely working. Okay, that should be pretty easy then, right? Well, there's one catch. He doesn't want his cartridge being unsoldered in any way. And I don't blame him either. With something this unique, I wouldn't want to risk it in any way. That's fine, we can read the ROM without unsoldering it. It doesn't sound too bad, right? Although it ended up being a bit more challenging than I thought, because I wasn't thinking straight from the beginning. This is a good time to thank PCBWay for sponsoring this episode. PCBWay is my go-to place for making any custom PCBs for different retro projects, and the results are always great. Normally I use them to build PCBs for existing projects, but as we'll talk about this later, I'm soon going to be starting designing my own PCBs, and that's definitely where I'll have them made. I started with the simplest possible approach. The EPROM had reasonably long pins coming through the PCB, so I thought about using a socket jammed right on the EPROM chip itself. I had a feeling that it might not work, but it was a really quick test, and so simple to test out that if not, I could move on to another method pretty easily. It turns out a normal 2-wipe socket doesn't make very good contact at all, but one with round pins seems to make much better contact. Only problem is, I don't have any 28-pin sockets of that kind. No problem, it's easy enough to cut one up and supplement the 24-pin one. There you go, something like that. And with some tape to hold it in place, maybe that will be good enough to make good contact. Maybe. Before even trying it, let's test it and make sure we have the correct continuity. The lines are mostly shared between the two EPROMs since it's just the data lines and address lines that are common to both. So we can test that we have continuity from most of the pins in one EPROM to the other. And yeah, this is not making connection, even when I press down in it. Oh, I see, in some places we're getting connection, but not in others. Alright, this is not gonna work. Time for the next approach. To get more reliable contacts, I was thinking of using a socket again, but this time putting it from the top, piggybacked on top of the EPROM itself. Then I can use some cables from the socket itself to the EPROM reader. To get an even better contact, I should have used test clips, which are the same general idea, but they make much better, much more reliable contact against the chip solder on the board. Unfortunately, I didn't have any at the time. Still, I managed to put it in place, and it feels like it's making pretty good contact, so let's check it. And yeah, as far as I can tell, it's all good now. As I suspected, connecting it to the EPROM programmer is a little bit tricky since the cables aren't very long and they need to be in the same orientation, so the cable needs to have a twist. But it looks like they're okay now, even though they're floating in the air. And that's fine as long as the connection is solid enough, so let's try to read the EPROM now. And it looks like it's just not reliable enough after all. It first gave some warnings about pins, so I rearranged the socket and then tried it again, and then the data I read back is clearly not good. I tried this a few more times, experimenting and pushing in with my finger and such, and I managed to get better data, but it was always a bit inconsistent, so yep, this is also not good enough. I think the problem we had was not so much the piggybacking, which actually felt pretty solid, but the cables going from the socket to the EPROM programmer. They would pop out whenever they were bumped and never seemed to get quite solid connection all the way. So now let's try the same approach, but instead of using those cables, I'm going to solder wires between the two sockets. That way the connection will be rock solid at least. So let's test that, and okay, the data looks a lot better and it doesn't have any of those weird repeating patterns. So did that work? Unfortunately not. I read the EPROM again and I got different data, so there's definitely something going on. At this point I was convinced that it was the piggybacking contacts, even though they seemed solid enough, but it turns out it was something else that I could have realized it at this point. It would take me one more attempt to see what was going on. So that didn't work at all. So what I'm going to do is I'm going to actually map the connections first, and then, and I think this is going to work, I'm going to use an edge connector, which fits here perfectly fine. It's too big, but it doesn't matter. And then I will solder the cables here going to the socket, and this should make a perfect connection. So hopefully with this, we'll be able to read both ROMs. And this is what it looks like. This is the edge connector for the SVI 328, and those are the two ROMs, 1 and 2. And there are no surprises at all. So pretty much everything is matching the correct label. So all the address bits are going to the corresponding address bits. All the output ones are going in the corresponding output bits. And even chip select 1 enables ROM 1, both those two pins, and chip select 2 selects that one. And here it is wired to the first of the two ROMs, the chip select. And yes, this is such a mess of wires. So now we should be able to connect this right here. And now we should have much better connections to all the pins in the ROMs. Now I was really confident this was going to work. Initially it seemed fine, but when I read it again, I got different values again. What is going on? And suddenly it dawned on me. And for extra shame, this is a version of what had happened to me before in a video a while back, replacing the ROM in an Amstrad CPC with an EPROM. In that case, I had forgotten to tie an extra address line to the ground, and I was getting random data every time I read from it. So have you figured out what I'm forgetting to do here? All the pins for the EPROM we're reading are connected correctly, but there are two EPROMs connected to pretty much the same lines. That means that the second EPROM is also being powered and is receiving the same address lines. Okay, but I already took care of connecting the chip enable line to the correct EPROM, so we should be fine, right? Wrong. What I forgot to do was connect the other chip enable of the other EPROM to 5 volts to disable it because it's active low. Since I let it disconnected, the other EPROM was answering some of the read requests and clashing with the results of the first EPROM in the data bus. I can't believe it took me this long to figure it out. Okay, so to fix this, all we have to do is add a new cable that goes from 5 volts to chip enable on the second EPROM. And of course, now it works and is totally reliable. Awesome!
And now to read the second ROM, we do the opposite. We connect the chip select for the first ROM to VCC and chip select for the second ROM to the signal generated by the EPROM reader.
And that reads the second ROM as expected as well. Great! The easiest way to check if the data we read from the ROMs is correct is just to use them in an emulator. In this case, I'm using Blue MSX emulator, which has full support for the SVI 328. I merged the two ROM files in a single one, put it as the cartridge ROM, and yes, it looks like it starts up correctly, just like we saw the cartridge itself on the computer. So I think the dump is correct. Now, before we do anything else, I want to read the two ROMs of the device that isn't working so we can see which one or both is the one that is not working. So let's compare them to the good ROMs. Okay, clearly the first ROM is totally busted because it returns FF everywhere, so it's all ones for every address. That's what happens a lot when you have damaged EPROMs. The second one, that is mostly the same, and it looks like it has a few different bytes towards the end of the ROM. And even the ones at the very end are just the company name and year, so I'm going to guess it's a very slightly different version of the ROM. Alright, now we have read both ROMs and the data looks fine. We have managed to preserve the 16 kilobyte ROM for this device, so that's a big step. Now we have to transfer that data to the initial cartridge that is not working. But before that, I wanted to look into what exactly is in the ROM itself. Because suddenly I realized that this is probably just a patched up version of an MSX ROM, which is probably completely illegal to sell commercially. So that's the 80s for you, I suppose. Let's see if that's true. I'm not going to disassemble it at this point. I'm just going to do a binary difference. It's not ideal because if they move a byte, everything is going to look different, but I have a feeling I know where this is coming from. If I run the difference against the SVI 328 ROM itself, it's clear that they're completely different. Everything is different. They don't seem to have anything in common. So where could they have gotten a ROM that was MSX compatible but not too different? Maybe from an SVI 738, which was the first MSX compatible Spectra video? Let's find out. And yes, look at that. It has a few blocks that are different, and I suspect those are the jump blocks, and a few bytes sprinkled throughout, and the message at the end, but the rest is all exactly the same. So yes, that's exactly where they came from. The last step in this process is to replace the ROM of the Folger cartridge with the EPROM programmed with the right data. But before we do that, there's one thing I'd like to try.
So this is kind of a long shot, but let's try reprogramming this EPROM. It read back as all FF, so all bits are on. That's the state that the EPROM will be in after erasing it. So I still think there's a really good chance that it's actually defective, but it would be fun to reprogram it without even having to take it off the PCB and desolder in it. So in order to do that, we can use our same adapter as before, configured to access ROM 1. The only thing is that there's this pin here, so pin that would be 27. That is the programming pin, and that is where the EPROM is going to receive a high voltage to let it know that we want to program it. And that is not connected to anywhere on the cartridge. So if you look in this track right here, you can see it's not connected to anything. And as a matter of fact, it's actually connected just with a blob of solder right there. So what I'm thinking about is using this adapter, but then soldering directly a cable from that to pin 39 in there and then trying to let the EPROM programmer do its job. And also at the same time, I'm going to have to remove that solder bridge right there. Oh, that one worked. So I was wrong. There is a PCB track in there. That wasn't just a blob of solder. There's a little PCB track in there, and after I remove the solder, it's still there. So we're getting connection between the two of them. So really the only way would be to remove that whole pin. And yeah, for that, I might as well just remove it. Too bad. I like the idea of reprogramming it right there. It would have been fun. Okay, fine. Let's desolder the ROM number 1. Because there's so much solder there, it's not going to be enough to use the desoldering gun in the back. So I'm going to do like I started doing with that other pin and use the braid as much as possible. I'm not going to drag it because I can damage the track. So I'll just put it in place and try to soak up as much of the solder as possible at each of the pins. Okay, that's pretty good. Time for the desoldering gun. So at first I thought it came out really nicely, but then I realized I pulled out several pads. Like that one, that one, that one, that one. They just came right up. Now, I thought, oh no, I'm gonna have to like make some kind of wire botches and things. But it turns out that every single pad that came up is a pad that was not connected to a track right there. So I think we're gonna be okay. The connection in those pads happens on the other side. That's where they're connected to other things. So we're just going to program a new EPROM. Actually, let's try this EPROM first, just in case to see what would have happened if we had managed to program it on the board. I still think that there's like a 90% chance or higher that is not going to work. And then if not, we'll program another 27C128 and put it there.
And as I expected, it fails completely when I tried to write to it. Oh well, it was worth a try. So let's just go ahead and put a good EPROM in there and let's program it. Perfect, this one was written correctly. Now let's solder it on the PCB. I'm not going to use a socket because it won't fit, but hopefully we won't have to replace it, so that will be fine.
So I just finished soldering this and I'm already seeing a problem. Even though I was very generous with the amount of solder that I put in because I really wanted to flow through, I think this kind of board construction, maybe the vias are not plated, or I don't know exactly what the manufacturing process is, but you don't get the solder flowing through the holes and making contact on the other PCB side. So let's even have a look at it under the microscope. Yeah, look at that. So those vias didn't get any solder at all on this side. There's no way they can be making good, reliable connection. And that's with me putting a lot of solder, as I said. Look at that. I usually don't go that heavy, but I suspect that it may be the case, and I was hoping it would flow through, but no, I mean, not a single one of them. So I think the only way to go about this is to put tiny bits of solder in the top as well, which is incidentally what they had originally done. I kept wondering, I wonder why they have solder there. That's why. And look how cool that is. This is the die of the EPROM at full magnification in this microscope. That looks really, really cool. Okay, so I'm gonna try applying some very, very thin solder to the top, almost as if we're doing surface mount soldering. And I'm going to do it on the microscope just to get a much better view. And yes, that seems to be working quite well. Perfect. Before we do anything else, let's make sure that it's actually working. I don't want to find out later that something failed along the way. And yes, look at that. It starts up and prints the correct message, so I think it's working correctly now. One last thing. I know this is not strictly necessary, but I'm going to peel the Windows sticker from the faulty EPROM by applying some hot air, and now I'm going to glue it on the new EPROM.
Unfortunately, they weren't the same brand EPROM, but at least it will look closer to the original this way. And as a last touch, I'm going to also mark the chip as ROM number 1 like it was done originally. There you go, fully restored. So we got the cartridge fully working, which was the main goal. And also, since there was no information about this device out there before, I made the ROMs and a scan of the documentation public. You can find links to them in the description. But I'm actually not done with this, and I want to make a few more videos about it. One of them will be on actually using the cartridge and how it does its magic and whether it's really effective or not. The other one is going to be to replicate this cartridge with an original PCB, and then maybe down the line taking the idea further. So that should be a fun start for me in hardware design. So anyway, I hope you enjoyed this video. Any feedback or suggestions, let me know in the comments as usual, and I will see you next time.
If you enjoyed this video, please consider supporting Noel's Retrolab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.